Hi, everyone. Thanks for joining us. This is Cassie Jordan here with TV Pipe Solutions. I have Don LeBlanc here who's going to be talking to us today extensively about grout. He's a 20-year veteran in the industry, has been doing this for a very long time. He has done many webinars about grout, and it seems like we can never seem to answer enough questions on grout. So we could be doing a lot more of these. Based on the questions you guys have already submitted, we have 2 pages full. If we don't get them through them in 30 minutes, if you guys stay on the call and I still see that people are engaging, we will keep going. If you need to drop off, then we will probably just do another webinar like this and a little chat that you guys can continue to ask questions. Thank you, Don, for joining us. Would you want to kick off a little bit, or do you want me to just dive into questions?
No, I'll just do a quick introduction. First, I want to thank you and everyone on your team for inviting me on board. Very passionate about this topic. This is something that I think is extremely crucial to discuss when it comes to grouting of annular space and voids and things of that nature in reline scenarios. But it's been great to be involved and to get to know your team. And thank you so much for inviting me to do this. Appreciate it.
Yeah, no problem. So I'm going to start sharing my screen.
All right.
And we will kick off here. I'm going to jump right into the first question.
Sure.
So what is this is more of, I know it's very high level, but what is the difference between concrete and cellular grout?
Sure. So there's a number of things, and there you go. There's a slide right there. So if you want to go ahead and advance that, there you go. Perfect. So traditional concrete is usually made up of several ingredients, including cement, some aggregate, maybe some sand in there, water. The difference between that and low-density cellular concrete is that cellular concrete is comprised of really only 3 ingredients usually. That is the cement, water, and air. And that air is created, you can see the shaving cream consistency on the bottom right picture there, through a liquid concentrate that gets blown through an air compressor after it's been diluted with water. So that creates the volume difference where normal concrete has stone and aggregate and sand in it sometimes, or flow fill has sand in it. That air is taking up those voids. It's a lot less. I should add one other comment that traditional concrete or flow fill is very heavy density wise. So wet density of flow fills can be up around 135-ish pounds per cubic foot. And as you can see on the slide here, our sweet spot is 50 pounds and less. So normally we're averaging between 25 and 40 pounds per cubic foot on the average.
Okay. And I didn't mention this in the beginning. I usually do my little housekeeping. I want you guys to be asking questions throughout this entire presentation that you have for Don. I'm going to be fielding all the questions that come in, trying to jump to the right slide as he's explaining, but I'm going to let him do most of the talking. But feel free to use that questions box on your control panel. We will also be asking you guys some questions that we are curious for answers on throughout this. Okay, another question that came in, why would someone want to use LDCC for annulus applications?
So great. First, LDCC is the acronym for low density cellular concrete. It's a mouthful, but usually, so low density cellular concrete, and there's a couple of reasons we'll go through here in the next few slides, but primarily it's because it's highly pumpable. All right, so if we back up a step, that slide is showing you the air voids that I was talking about and the volume space that I was talking about, where traditionally in normal concrete, you would have those aggregates or sands filling those voids.
Okay.
So if you want to go ahead and advance, Cassie.
Okay.
So you can see here that this is our normal chart for, there you go, cellular concrete. And average compressive strengths are usually very high compared to traditionally well-compacted backfill. So when it comes to filling voids behind hose pipe walls, you know, like when we talk about lining your average corrugated metal pipe, what have you, or anything with a void behind it, right, with retaining wall, bridge abutment, so on and so forth, the ability to pump this material is very high because it's such a lightweight mix. And it's giving you something that has a compressive strength that's significantly larger than your average compacted backfill. And so that's why cellular concrete makes a good annulus fill material. To answer, I guess, one part of your question a second ago, is that it's just a really good material to give you a nice compressive strength and a void space that is otherwise hard to get to, right?
Yeah, so this is and I think you're sort of already answering this question, but since someone asked it, I want to bring it up. One of the products we represent, you and I collectively, is Snap-Tite, and in their design guide, they recommend cellular grout. And why is that?
There's a number of reasons, but if we were
Yeah,
going to hit maybe
it's going to be a big answer,
top,
but I figured we kind of probably get through it as we talk today.
absolutely, yeah. I think, I'm not quite sure directly why they would have chosen it back 30 plus years ago, but except to say that I know they had great experience with it, with pumpability and flowability. And I think only in the last 20 to 30 years, the technology has advanced. Not to say, and we'll talk about this throughout the course of today, flowable fills are often successfully used in shorter run culverts for lining and things of that nature. But usually because of its sand content, it can become a bear to pump and or gravity fill those voids when they're longer pipes. So I know from a fact, in my experience in working with Snap-Tite, that its pumpability and its ability to fill voids and get through to the other side of the culvert has always been a really good reason for why they would recommend it in their design guide. And again, we just continue to grow with utilizing this technology.
Okay, and we got a really good question in the chat box. Why would you recommend the use of LDCC? Sorry, would you recommend the use when water is in the annulus between the hose pipe and the liner pipe? And will the typical guidelines for cellular concrete mixes slides be available to us? Yes, I will send those out if you guys would like.
Absolutely. So yeah, so the question is, will it, in the presence of water in an annulus space or voids, let's say, is cellular concrete a good idea to utilize? It's a bit of a loaded question. I think a couple of things, it's a great question. I think a couple of the things that should be considered is that water stagnant water? Is that water that, you just had a 5-day rain event and you've got water gushing into that hose pipe while you're trying to line it? Is it coming in above you, overhead, in a larger culvert? These are all, you've got presence of groundwater just seeping in at your 12 o'clock or what have you. These are all good things to consider. And I would say if it is stagnant water, it's quite possible you can force that water out by head pressure, meaning as soon as that grout starts to fill that annular space, it'll start to displace whatever residual water's in there. And as you know, Cassie, and most of the folks on this call, I think, have had some experience with it, you can usually displace that water out of your ports at the bottom end of your bulkheads. But if it is the opposite and it's a good amount of water and it's become a nuisance, there's been scenarios even recently. We just did one out in Buffalo, New York, where there was a lot of water coming into the annulus, and we were able to displace it and get rid of it utilizing a cellular grout that is actually above the weight of water, density-wise.
Okay.
Yeah, so, weight of water being 62.4 pounds per cubic foot, if you use a grout, whether it be flow fill or cellular, that's, let's say, 70 or 75 pounds per cubic foot, you can usually succeed in that fashion. Yeah, there may be some extreme cases where you need to, quote unquote, leak stop or help stop the leaks from becoming a nuisance for you. And in that sense, you might consider pre-filling those voids with some sort of other type of grout, or waiting till a drier day, for example. That may be other ways to tackle that annular fill.
Okay.
Great question. Love it.
Yeah. Thank you for that. Okay. So I have another question that I'm going to get to in a second on chat, but I have this one that came in, and you and I discussed it briefly a couple of days ago, and I think it's an important one. Can you explain the various densities and why you would change densities based on projects?
Yeah, that's a wonderful question. We actually talked about this morning on our team call, and I think it's a great topic. all too often I see a lot of compressive strengths, whether they be in DOT specifications or just a private job specification. And the compressive strengths, you'll notice countrywide, will vary depending on the owner and the final design needs. I absolutely encourage everyone, whether it's a DOT or whoever the owner or engineer may be, to go ahead and specify a compressive strength, bearing in mind, and this is good we bring this up on this chart, Cassie, so thank you, that the compressive strengths on this chart are significantly greater than, again, a well-compacted soil. So I often encourage folks to lighten the density, the wet density of the mix, because as they'll find during their design, unless there's some extreme live and dead load on that pipe, even the lower strength or lower density grouts will suffice, and then also have a factor of safety built into it. So yeah, it's oftentimes, they're shooting for 500 PSI, 1000 PSI, and those are really flowable fill type strengths and then some, right? Whereas on the average, we'd be somewhere between 100 and 300 PSI, typically speaking. And that's, most of the time, that's sufficient. But it should be checked always.
Right. I'm going to ask the question that came into chat. Is there a max distance cellular grout can be pumped if a project is 2,000 feet tunnel, for instance?
That's a wonderful question. To date, in my experience, and I think, depending on who you talk to, everyone's experiences are going to be slightly different. I can tell you from some case histories and some bulletins that we've had success on projects pumping several thousand feet, 10,000 feet plus. So you're talking miles.
Yes.
There's a number of things that go into those considerations, i.e., what's the density of the material you're trying to pump, right? So, in situations where you're trying to pump further distances, it may behoove you to utilize a lower density grout. The type of equipment that particular installer is using to pump that distance, usually the installers that you talk to in the cellular concrete world will know what their machines are capable of pumping distances are. But we've had 2 projects off the top of my mind I can think of where we've pumped over 9,000 feet in distance. Several, the one I'm thinking of specifically is one in Washington State, was a wastewater big conveyance line, and that was like 70,000 yards of material in annular space.
Wow. Yeah, there's a huge washout project we have going on right now that's a lot of grout.
Oh, yeah.
Good. So I'm going to just keep going here. I don't even know what our next slide necessarily is.
Sure.
You kind of talked about this a little bit, but what are the costs of cellular grout compared to regular sand or cement?
Yeah, and so there's a little bit of math which I won't go into today. I encourage anyone on the call to reach out to me and I can help. There's obviously, it's sort of like any fine prescription medicine, you got to read the fine print, right? So a lot of things go into pricing, and those include even regional pricing. But bear in mind that, I guess the one comment I can make that's a commonality, no matter where you are in this country, is if you start at 60 PCF, for example, and you actually are able to design instead of 60 with 30, you're helping that customer or that owner with the final price. Because remember, cellular grout is cement, water, and air. And I always joke that, the manufactured air should be the cheapest component. So the fewer pounds of cement that you have in your yard design, per yard design, that's going to help the owner and the designer with a more cost-effective solution. If I was going to give you a more direct answer, Kathy, I think I've found examples here in New England where we've been right on point with flow fill. I've found a few examples where we've been a little bit more expensive, on the order of $20 to $30 a yard more, but ultimately the contractor or the owner will choose the cellular because they're not having to open up a hole every 60 feet to pump or gravity feed flow fill. So they're saving on the amount of excavations or the amount of hookups and time they spend trying to get this flow fill into this void space they're trying to fill.
Right.
not specific to Reline, but as a really good correlation for the folks on the call, I have some municipalities here in the Northeast that are switching their pipe abandonments, that's gas, water, sewer, all their abandonments are starting to switch to cellular grout because they know they can pump it hundreds of feet successfully. So instead of 10 holes for that 1 mile stretch, they might only have to open up 2 or 3 to do the same thing.
Yeah, and this slide that we're on, that's a great point because we have a lot of actually DOTs and municipalities on this call right now, quite a few registered.
Wonderful.
So we're on the perfect slide to talk about that just briefly. This is, you and I have discussed it, but just specifying grout, this is your recommendation, right?
Most of the time, yeah. Again, there's been folks and owners and installers who've had success utilizing flow fill right off the back of the ready mix truck in shorter applications, right? So on your average street culvert where you have some time and it's maybe 50 or 60 feet long, I don't want to generalize it and say all, but most of the time flow fill should work okay. But once you start climbing above that 50, 60 foot mark, it can present some challenges in getting it. So I always encourage, my message to any DOT or owner is go ahead and specify the type of grout that you want to benefit your design, and just know what your compressor strength is going to be, because ultimately, all too often, it's grout to be per the pipe manufacturer or something like that. Some sort of verbiage falls into the spec somehow. And, the grout is just like anything else on that project. It's something that you can and should, in my opinion, specify. So I am passionate about that. I think it's something that certainly can be taken care of.
So I'm going to move us forward on the slides. Most of the questions that I have had submitted and that are starting to come in on chat they're all install questions. So I think we've got plenty of install slides that we can kind of start addressing a lot of these questions.
Wonderful.
So this one is just kind of a general overview, right?
Well, yeah, so I include this slide, and this is actually a sort of a condensed version of a webinar I gave a couple of weeks back. But I wanted to include this because I don't want to generalize this all to cellular grout. There may be even some that you guys on the call have seen or utilized or specified yourself that I haven't got on this slide. But here in the Northeast, these are somewhat common, with the most common being at the top, right? So cellular concrete, flow fill, as we've discussed, are two very commonly used ones. CLSM is another term that kind of falls in that flowable fill family. Controlled low strength material is what they call that. And then on some of these larger span bridge jobs where they've been, long span, like 20-foot plate style bridge jobs with very low cover amounts, I've seen self-consolidating concrete used as well, which once again, very heavy. So we got to be cautious of the buoyancy forces and things like that are being utilized or put on the liner pipe. But it is something else I see being specified very seldom for those larger jobs.
Okay. Now I think we're getting into some install stuff. I'm going to jump into this.
Sure.
So one of the questions was, what is the ideal pumping pressure for grout in an annulus application? That was a question that came in days ago. But we on chat have a question, and you and I talked about this at length just a couple days ago. Does grout pumping pressure need to be considered for HDPE and other types of liners? So that's, I think more enough that it's going to be the same answer, but you and I have talked about this. I think this will be good to give to the group, though.
Yeah, it is it's probably the single most concern when it comes to grouting of an annulus, right? Is most of the time we have a provision for blocking the pipe against buoyancy, right? And then the question becomes, what kind of pressures are we going to put on the liner and or the annulus, and even the bulkhead, right? If you've got a bulkhead that's got a lot of lateral liquid pressure on it, that's something else that can and should be considered. And so what I find that is that to answer the question a little bit more directly, pressures can be found or can be exerted on a pipe in many different ways. Liquid pressure, head pressure, as we talked about earlier, right? There's the pump pressure, there's the pressure at the hose. But the key is really the grout pressure at the pump may vary depending on the equipment. But what is crucial is that you always talk to your lining manufacturer, whether it be Snap-Tite or someone else, what should we limit those pressures to, and then ask them more deeply where do those pressures come from and how can I mitigate those risks.
And we talked about this depending on manufacturers. So you and I work with lots of manufacturers, whether it's Context, Duramax products, solid wall HDPE, profile wall. So it really depends on the weight of the pipe, right? On how much pressure it can handle.
That certainly is a buckling resistance, but if you've got a very lightweight pipe versus a heavier pipe, that's all downward force that helps you and aids you in the counterbuoyancy calculation. So if you've got a pipe, for example, that weighs 300 pounds a foot, and then similar pipe of a different material might only weigh 100 pounds a foot, that is something that you certainly want to consider in those calculations. Yes, so you're absolutely correct about that.
Okay, and then this leads right into the next question of how do you manage grout pressures to prevent collapsing of the liner pipes? Do you want to dig more slides before we talk about that?
I think, definitely, please bring it back up, though. It's certainly something where, as you know, we could probably have an hour conversation, and I don't want to submerge this conversation in that. I would boil it all down to one statement, and that's always talk to your lining manufacturer and ask them, where do those pressures come from? What do I have to watch out for? And educate me on, ask that person to help you out in figuring out where those pressures could come from. That's the one generic comment I'll say.
Okay, perfect. I'm going to move ahead. So we've got this is a really cool video. Do you want to tell us a little bit about this project?
Yeah, and so to give some context here, folks, this is a DOT, New York State DOT, where that's me in the blue helmet there and the hard hat in the center page, showing some New York DOT folks how to install Snap-Tite, which is a solid wall HDPE, terrific for lining culverts. This particular one was a beautiful day in the middle of farm country, upstate, beautiful New York. And this was 32-inch Snap-Tite going inside of a 36-inch CMP. What they did, and I learned a boatload from contractors, as I'm sure you do as well, Cassie, is they simply, they do. They certainly do. So on the right-hand side picture, before she shows this video to you all, you're seeing basically just plywood 2x4 and a little bit of orange. That's an upside down traffic cone with a catch basin grate on top to catch any solids coming off the truck that they don't want going into their PVC. And you can go ahead and click that. Basically, this is flow fill. So this is, and there might be a little lag on your video at your office, folks, but this is extremely flowable, right? So we call this like 11 or 12-inch slump. It's probably even better than that, but it's still got a lot of density to it. And so I like to show that video to show you that flow fill is flowable, but bear in mind it still has some density to it, some liquid density to it.
Okay. Oh, it's playing this again. There we go.
Yeah, there you go. So you asked, go ahead, you have a question?
I do have a question.
Sure.
So we're not quite to the blocking slide yet. I know you wanted me to kind of bring this up then, but how do you determine the number of grout tubes needed?
Yeah, so there's some great literature available. There is some installation guidance that is provided to the industry through Snap-Tite's design guide and installation literature. And a lot of those similar theories can be utilized amongst various lining manufacturers, right? So just good practice for how many tubes to use. And it's not the Bible by any means. The contractors have succeeded using other solutions, but it's a good practice to utilize. So the number of ports and or PVC tubes that you utilize can be per your decision. I would say the one thing that's going to govern that is what type of material are you using to fill that annulus. Is it going to be flow fill? Is it going to be cellular concrete? Because again, as we talked earlier, low density cellular concrete, you can pump hundreds of feet. So you don't need to, in my opinion, you don't need as many ports as staggered lengths as you might need with like a flow fill or something of that nature. So it's a good question. Certainly, every project is different, but it is something that Snap-Tite has some great information on that can help folks on the call.
Okay, perfect. And that's in the design guide, correct?
Yeah, so you'll find some info in the design guide, but you'll also find some info in their installation literature as well, of which they have a couple of different. They have like a flip chart, and they also have an installation guide. Both are in process. They both exist right now on our website, on Snap-Tite's website, but they're both being updated to have some other terrific information for folks to utilize.
And for a couple of the manufacturers I know we have on the call, Contec, I believe, is on the call. We've got Spiralite on the call. Can you guys shoot me a chat or just a note? Do you have grouting guidelines available for various products? Just let me know and we'll come back to that. Is there anything specific you want to show us on this slide?
Yeah, so I mean, a few different points, right? So folks will often ask, and even at the top end of the call, we sort of ask this question of each other: why low density cellular concrete? Why did Snap-Tite put that in their design guide to begin with, right? And there's really, just kind of scraping the tip of the iceberg here, there's 4 reasons that I can think of off the top of my head. And in short, one is the buoyancy forces, right? So there's much less buoyancy force on any liner pipe, whether it be steel, HDPE, solid wall, profile wall, you name it. The uplift force or buoyancy force on that liner is greatly reduced when you utilize cellular over flowable fill. And I just did a little example there in the yellow text. So you're reducing your buoyancy, and inherently you're reducing your collapse and buckling pressures on that pipe. Highly pumpable, right? So it's self-leveling, it's flowable. Not only are you going to fill the space between the liner and the host, which we in the industry call the annulus, but you're also going to fill, if you see the picture off to the right here, that's from a New Jersey project. That's actually an old railroad culvert that had some significant voids, as you can see, beneath the spring line. And this thing, you could actually go in it and sound it just by using a rock or something like that and hear the audible difference in where those backfill voids were actually getting worse. And inherently, they had sinkholes up above near the railroad bed. So, when you're talking about making sure you fill a void and it being the annulus, but also the voids behind the hose pipe, you're re-engaging that backfill envelope. And that's hypercritical in any lining situation.
Okay. So we're getting close to time. We've got lots of people engaged. I still have questions coming in. I'm going to just let us keep going, if that's okay with you, Don.
I'm here until you tell me otherwise.
Okay. So what are we looking at here?
So there should be a video file on the right-hand side, and this is actually a geotechnical application at UMass Boston. I put it in this presentation. It's not directly related to pipe fills or annulus, but it is nice to see how flowable this material is when it comes out of the hose.
Right.
And so I simply share that video to kind of give you an idea of how much you can really flow this stuff.
Okay. So here's the grout tubes again that we've kind of been discussing, and we've sort of addressed the question of how often or how many should we put in. Another question that came is there a max, the largest number of lifts that you have had to do on, what is the largest number? Sorry, excuse me for reading that wrong, to do on one reline?
That's a great one. If I were to think, I want to say 5 or 6, and it wasn't a function of the vertical height of the culvert. It was more of a function of the pitch or the slope of the culvert. So that's one critical thing that I don't think we've touched on yet today. But obviously, if you have a pipe that's 10% pitch, let's call it 20% pitch for extreme, versus a pipe that's flat, maybe 1 or 2%, those two pipes are going to grout a lot differently, right?
Right.
You'll get a nice equal distribution on the bottom of a flatter pipe, but if you've got a pipe that's pitched quite well, all your grout's going to want to float to the bottom. So that liquid pressure on that pipe has to be considered, and the bulkhead for that matter.
Right.
And so, some of these pipes that are steep, we deal with a bunch with Pennsylvania DOT, out near Pittsburgh and Cranberry area, where underneath those highways, there's this crazy amount of pitch. Also in the Finger Lakes region, in New York and wine country there's those pipes start high and end up really low at the outlet. So we got to be cautious, or at least cognizant of what is going on with the grout there. So I'd say 5 or 6 maybe might be my most amount of groutless that I've experienced personally. Could be even more.
Okay. So this is an interesting question. Can you give an example of pricing you've seen recently on a project, maybe on an actual a price per amount of grout? I'm trying to word this correctly. Does that make sense?
No. Yeah, it does. And I would say, so based on volume and regional market differences and things of that nature, I'm going to give a range. Okay, so I've seen annular fills. Actually, just priced up one this morning. I've seen them range for about anywhere from $135 a yard in place to as much as $350 a yard in place. Normally, what the industry will do, or what the installers will do, is that per yard price includes everything, right? So that's mobilizations are considered, labor's considered, prevailing wages considered, everything. So it can be quite the span, but I always encourage folks to ask the question, hey, call me, call Cassie, call anyone, say, how much, if I have a 100-yard annular fill that I need, go ahead and dial them up, and they'll put you in touch with 2 or 3 individuals in that general area that can do a cellular grout job for you, and then you'll actually have a known price for the job. So just like any lining solution that we provide, that Cassie and I talk about, grout fill can also be the same conversation. What are you seeing for regional prices in your area, so on and so forth.
Right. Great. So here we talk a little bit more about the tubes.
Yeah. And so this one, again, I put a little asterisk there, courtesy of Snap-Tite. This is not Bible, but it's great, great guidance. It's not, it has been super successful for our team and others over the course of many, many, many years. So it's something where, if you have an installer, contractor, municipality, DOT that's self-performing a lining, this is really good general guidance to use. And you may choose to do something slightly different, but if you're looking for some sort of input, I would highly encourage you to research this and look at this.
Yeah, and we can send you all this this literature.
Absolutely.
All right, what's going on this one?
So this is, I call it the sort of the older school method or mentality. This is something that's very common to folks still. This has been around for decades, right? This is where you would foam the back of a ready-mix truck. And I would tell folks, if you're looking to do a smaller job, smaller annulus job, some jobs we're talking as low as 2 or 3 yards of fill where you can bag mix it, right? And then some jobs, I'm looking at a job right now, it's 1,200 yards of annulus, and that's as neat geometry. It doesn't even include any voids behind the hose pipe. So we'll talk about those bigger jobs here in a second. But if you're looking to do, I'd say, up to 100-yard annulus relatively effectively, you can do that off the back of a ready-mix truck. And so what you're seeing in this diagram is the foaming cut, sort of the layout for foaming the back of a ready-mix truck to end up with low-density cellular concrete at the end of your hose. Okay. So this is a generic layout for folks who are looking at what is involved in cellular concrete.
Gotcha. And this is a video, right? Yes.
It is. And so when we talk about foam and air and manufactured air, it's you talk about selling hot air, but this is basically where you are seeing the air is being introduced to a foaming nozzle, and you can see how uniform this material looks. So there's some sense in talking about foam quality or bubble structure when you're talking about the foam, and that's what you're seeing here. This is just a video I took in their lab where you're seeing the foam come out of a nozzle. You can see how nice and uniform it is.
Yeah.
So just an example, this is the foamer in the back of a pickup truck on the right-hand picture there. And the individual on the truck there is just foaming the water and cement slurry, and that turns into cellular concrete, which he will then pump into the annular space inside the in between the liner and the host, which I think is on the next slide, Cassie.
There you go.
There you go. So this was a 54-inch solid wall Snap-Tite HDPE high density polyethylene liner inside of a 60-inch corrugated metal. The reason they line this culvert is because you can see just behind the excavator there, that's actually, they're repairing these bridge piers for their brand new bridge just over I-95, just north of Portland, Maine. And so in an effort to minimize disturbance, you also have the highway right off to the left side of the excavator there. So trying to remove this culvert would have been a pretty involved project, so they opted to line it. And then you can see in the right-hand picture the actual grout tubes up just at 12 o'clock basically, and some vent ports and stuff like that off to the left-hand side around 9 o'clock and maybe 7 o'clock there. So that's the finished product right there.
Gotcha.
So now, for folks who haven't seen this, I call this basically a newer, even though it's been around a little while. It's fairly newer compared to foaming the back of the ready-mix truck. So the concept here is that instead of foaming the back of the ready-mix truck, you can foam in line of the concrete hose itself at that. There you go. There's your cursor. So if you could highlight over that inline foam injector just south of where you are, Cassie. Mm-hmm. That's where the actual blending is happening of the foam and the cement and water slurry to give you your finished goods at the end of the hose.
Mm-hmm.
So that allows you to take now, instead of a partial truckload that you're foaming, you're now getting a full truckload of slurry and producing your finished volume at the end of the hose.
And does someone have to rent these? I mean, or do they have someone come out and do this for them? I guess that's a Cassie question. I don't know.
No, wonderful question. So normally the industry folks will not rent them; they sell them. So they'll sell foamers. So that the blue thing on the left-hand side there, that 4x4 skid, the blue skid, they'll sell that. They'll also sell the one that you saw in the back of the ready-mix truck for that Maine DOT job. That's a foamer as well.
Okay.
And then if you're any sort of concrete, if you're a contractor, you may already own an air compressor and a concrete pump. And so you can self-perform that as long as you have the foaming technology and the grout pump, right? There's a number of established folks in the industry that already have the equipment to do this. And so anytime you're considering cellular concrete, call around and ask, or just call one of your Snap-Tite reps or Cassie or I, and we'll be able to point you in the direction of a couple folks local to you that already have this equipment and can produce the cellular concrete.
Yeah. Okay, perfect. I am going to move us forward. Oh, here's your arrows. I was behind.
That's all right.
So this is a good time for me to ask this question. We've heard you say that quality control is measured in the field, and you're showing these guys in the field. What adjustments may need to happen if they find out something's wrong or something's coming out too high?
So I joke, but I, in all seriousness, the analogy of I like to cook, right? So adding salt to a recipe, adding foam to concrete or cellular concrete is the same idea. So if you're a little heavy at the end of your hose, let's say you're targeting 40 pounds per cubic foot and you end up at 48 or something like that. The key is to go ahead and add a little bit more foam so you can lighten it up, because the air bubbles is what makes it so lightweight, right? So just checking the density at the end of the hose is per ASTM all you need to do to check the quality control of the material.
Okay.
If I've learned anything, Cassie, in my time with cellular concrete, checking your checks and balances, everything. So sometimes if it's a really delicate project and you really need to hit the density on the head, as simple as checking even the neat slurry coming off the ready mix truck before you foamed it can be a critical measure in making sure you get the right product.
Okay.
So it's like anything. As long as you weigh it and check it and it's right where you think it's going to be, the weights will give you your finished compressive strength at the end of 28 days.
Okay. So I believe we have a blocking slide. Maybe we already passed it. If you miscalculate the density of the grout and the pipe starts to float during the grouting process, what are the steps to correct that?
So I don't think we have passed by our blocking slide.
Okay, so we'll get to that.
Do you want to tackle? Yeah, please bring that back up.
Okay.
So this is the project, one of the projects I was referencing earlier when the question was asked, which was great. What's the longest, I think, or what was the biggest volume? There was a question along those lines. And I was not directly involved in this project, but through mutual colleagues, this is a case study that we have on basically behind that wooden and steel bulkhead in between those four pipes is a massive annular space. And that was pumped, as you could see. Yeah. 70,000 yards of volume that we had to fill. So that was done through the utilization of cellular concrete.
Nice. That's a huge project.
It is. Same project. And the reason I correlate this to our subject matter is because what you're seeing in the elevation view images on the right-hand side there with the two circles inside of each other is the annular space that we're talking about, the space between the liner and the host. And so we talk about, we want to encapsulate the liner, but we also want to fill the voids outside of the hose pipe and make sure it's highly flowable so that we know we're going to have a successful project and we can pump, thousands or hundreds of feet in most culvert applications, right?
Right.
And so what you're seeing there is just some pressure ports so they can gauge how much pressure they're getting, and then vent ports, those are basically ports in the wall of the pipe. And I know Cassie, you had possibly set up a poll. Did you want to ask that at this time?
Yeah, I think that's great. So who is familiar with grout ports? I'm going to launch that poll and we can actually all see as the answers are coming in. So we have half of you voted so far. I'll leave this up for maybe another 20 seconds. Oh, look, I even have a timer. It says how long I've left it up. Polls a lot. These are fun though.
There you go. I like it.
Yeah. Because you and I were talking this morning when we had our call. I'm only very, very baby familiar with grout ports, right? But then there's some of you that you've been doing them for years and have a much, wider knowledge than us. Okay, you've almost all voted, so I am going to close this poll. I'm going to see. So let's say we had 76% of people were familiar or are familiar with grout ports and 33% are not. So that gives you a good idea. So one more poll. So for the 67% of you that are familiar, who's actually used grout ports?
I like it.
Yeah. So we've got a third who not familiar with them at all. And now I'll be curious to see out of the 2/3 who are, who's actually used them in the field.
Absolutely.
Right now,
so as you can imagine, go ahead. Sorry, Cassie.
We're about 50-50 and people are still voting.
Okay.
More than half. Oops, my number just jumped up. So people are still voting. Okay, so I think that's good. We're about a 60% have not used them, 40% have. That's
Okay,
that's interesting. I think that's interesting.
absolutely. It, in short, grout ports do a number of things for you, in my opinion. One, it gives you more ability, more viewing points. If you're installing 1,000-foot run of whatever, and you have access to that liner, the grout ports allow you the ability to view how the grout's doing. Um, Obviously, if it's a smaller diameter pipe and you're not going to get in that pipe, grout ports are almost essentially a moot point. There's no sense in using them. But if you're in a larger pipe and you can utilize them to view the grout on both sides of the pipe, or as you see the 12 o'clock arrow there,
Yeah.
that may sometimes be used to block the pipe during flotation or against flotation.
Okay.
So there's a number of reasons why you may use them or why you might consider using them. And most of the pipe manufacturers that we deal with will have the ability to attach or insert or manufacture them into the pipe.
Okay. This looks like a nice project.
It was certainly a great project. For those of you who have been to Maine, if you're familiar with LL Beans, you're getting yourself some winter boots or what have you. This is about a mile north of LL Beans, and the road was sagging. You could see the failure happening in the road in the pavement above here. And you had just kind of a neat old stone structure that was assembled on wooden logs. And so we ultimately ended up choosing a solution called tunnel liner plate. And you can see in the picture on the left, the bulkhead with the ports coming out. It's kind of small, but you can see the ports coming out of the bulkhead. And in the center, you see the inline injection machine with the grout pump on the left-hand side. And I'll show this only to say that you don't need a massive void. You don't need a 1,200-yard job to consider inline injection. This was totally worth it because you were able to do the annular fill and the void space in between all those little rocks a lot faster with this solution.
Right. Here's a little more on that job.
There you go. So you can see the hose hooked up in the center picture there.
Yeah.
And you can, on the right-hand side, you see that blue connection where the foam is being made and it runs into the grout line as well. So that's in the picture on the very right-hand side.
Nice. Just another project, right?
Yeah. So, I mean, we have the benefit of having some beautiful scenery here in the Northeast when we're out lining culverts. So this is in the smack dead center of the White Mountains for New Hampshire DOT. And in this instance, the contractor had to basically run about 700 or 800 feet of hose, Cassie, to go ahead and install that grout down beneath. It was almost exactly parallel. If you can imagine, the Conrail Railroad was there, and you also had Route 302 going up through the White Mountains, and that culvert fell smack dab in the center.
Wow.
So it is actually the beginning of the Saco River, which exits right here in my town in Maine. So this culvert's right at the head of the Saco River up in the White Mountains.
I do love that area.
Yeah.
All right, so back to blocking. If you were to miscalculate the density of the grout and the pipe does start to float during the grout process, what are the steps to correct it? I'm assuming this is the slide we were waiting for.
No, so this is probably, it's really a great question. So I would say immediately, the first step that I might take is shutting down the grouter, right? So stop grouting immediately. If your pipe's floating, that could be most commonly maybe there wasn't enough blocking or any blocking in that scenario. And in that sense, if it's a man entry pipe, you might consider going ahead and doing what you see in the top right picture there, which is let's go ahead and core some holes in the ceiling and put some pipe jacks up through that ceiling to pin into the hose pipe wall, right? So that in that image on the left, that's an elevation view essentially showing you the concept.
Got it.
So you've got a steel column that's pinning into the ceiling of the hose pipe, preventing that pipe from floating. So If that pipe's floating, number one, shut down the grout pump so you don't continue to float the pipe. Go ahead and examine, consider what blocking's in there. If there's none, or if there's limited blocking, you may have to go ahead and manipulate that before you continue grouting. And I love this question because there's a few ways to skin this proverbial cat, right? Is you may consider lowering the density of the grout that you're using as a solution for that problem, right?
Right.
If you're in there with a flow fill, for example, and you learn that cellular grout would be acceptable for your project, that will help reduce your buoyancy force on that liner pipe. So it's certainly one method or one way to mitigate that concern.
Gotcha. So I do have a couple more questions.
Sure.
I think this one is really crucial, and I've kind of saved it to the end, which I think we're getting almost wrapped up here. What is the most common thing that can go wrong during grouting?
That's a great question. I think we've sort of hit them on the head. I think a little bit. One would be float the pipe, right? So I think the most common thing and the most probably the easiest thing to prevent is floatation, right? And what is our concern with floatation? Sometimes there's none. Most times, you're trying to keep that invert nice and low, the invert of the liner pipe, nice and low and tight to the hose pipe. And so you're trying to prevent the water surface elevation from becoming too high. So keeping the liner nice and tight to the bottom of the hose is often important to the owner or the installer or the engineer. And so I think the most common thing that could go wrong, but that we prevent by having these discussions, is blocking the pipe. Secondarily would be damaging the pipe, right? So whether that's one little local deflection that's unwanted, or even worse, could you actually buckle a pipe and fail a liner? That would be the worst case scenario, right? I've been fortunate in my time not to be privy to anything that has happened in that capacity. But I think grout, and I love that we're doing this, and once again, thank you for inviting me to do it, is I think grout inherently has this, for people who want to talk about it or who have talked about it in the past, it's one of these things where there's concerns, there's questions, there's maybe there's not as much experience to the individual or the designer that's using it, right? So for me, these are the kind of conversations that are critical, but also important for us to have on the day-to-day when we're designing these liners to prevent anything from going wrong. And we're here to help for sure.
So this is another question that came in. When would you spot repair an area that you drilled the hole for the pipe jack? Or would you then spot repair?
So the question is, would you, or when would you, or both?
Would you then spot repair? Yeah, for the area that you drilled the hole for the pipe jack.
You certainly could, depending on the type of material. So there's a number of ways to do that. If you're using some sort of HDPE, whether it be profile wall, solid wall, steel reinforced HDPE, there's a number of ways to go ahead and repair that hole. More commonly, there's an option to go ahead and buy off the shelf a threaded coupler and tap that pipe. You drill and tap the pipe, and you use a threaded female receiver, and then you go ahead and cap that port. So it's just a permanent solution. It's in there forever. Putting grout ports inside liner pipes as a general statement does not damage or risk damaging or anything like that the structural design of your liner pipe. But it's always worth checking with any manufacturer, how many should I put, how often should I put them, and that's going to be a two-way conversation between you as the installer or designer and the pipe manufacturer, because hey, I want 5 ports at every 20 feet, or I don't want any ports because I don't want any holes in my pipe. That's a quality concern, and I would understand why an owner might say that. And in that sense, if you've got no ability to port the pipe, or you don't want to because of just you want a nice aesthetic smooth pipe at the end of the day, you almost always want to use a cellular grout, in my opinion, because you're not going to have, if your only entry points for your grout are at the ends and you've got some distance in between there that might be a question mark at any given point and no ports, flow fill is going to probably give you a headache or two. So I would say utilize cellular grout in the areas where you have no ability to put ports in.
Okay, excellent. So we've got about 4 or 5 minutes left. I'm going to wrap us up at the hour. We've gone a whole hour on this.
I love it.
I knew we would, but we haven't lost anyone. So that's exciting.
Good.
People want to hear about this. Obviously it's a hot topic. We're probably going to need to do it again soon, Dawn, because
Sure.
I've had so many questions. I know there's a couple more slides. I have one last question I want to ask, and I think this will be a good one to wrap up. And I think this is kind of one of your final slides, is what tips or tricks, if any, help speed up the process of getting ready to grout?
So getting ready to grout or actually grouting?
It says getting ready to grout.
Yeah, so that's a good question. I think utilizing the vent tubes per the recommended, when you can stagger your vent tubes and if you might have the ability to it's a man entry size pipe, you can often pre-sling or pre-hang your grout tubes, so that way you're not trying to stuff them in kind of last minute when you're constructing your bulkheads. So let's say, for example, you're in a 72 or an 84-inch corrugated metal, and you have the ability to get in there and just use some channel iron and connect your PVC tubes ahead of time, and you slide your liner pipe and you start grouting. That's one way I can think off the top of my head to go ahead and speed up that grout process, or getting ready to grout. I think also if you can have an area where your neat slurry, if it's ready mix trucks or what have you, have a nice area or a lay down area or working area where you can go ahead and set, have your ready mix trucks coming in, have them coordinate with your supplier, your ready mix supplier. Make sure, hey, I'm looking to have 5 or 6 trucks lined up for today. Do you have that ability? There's a number of things that you can do to prepare and prep for grouting procedures, and that's, there's a lot of good steps that can be taken for sure. Okay.
Well, I'm going to let you wrap up with this last slide, or these last couple of slides, and we'll let everyone go.
Sure. For those who are interested, this slide is really, and again, Cassie and I can share this with you. This is sort of 14 bullet points that I share with folks, so that if you're working on a spec, or you're putting a spec together, and you have some expectations of that installer to meet when they send you a submittal package. I'm not saying it's critical you add all 14, but these are, if you get a submittal package that includes some of these, you've done a good job of making sure that contractor is ready to install the material, the liner and the grout. Things like, how are you proposing to do the grout? What type of grout are you going to use? What are your grout volumes? And how are you going to mitigate against any floatation force or buoyancy force? These are all things that can be discussed right on the front end. And if you're talking to an installer or contractor and they say to you, well, I'm going to grout the whole thing in one shot, right? That's an immediate question mark for you. It may be feasible that that's possible on any diameter, but usually when you're talking about larger pipes, something that's 54-inch, 60-inch and above, there's possibly going to be more than one grout lift involved in that project. And so you always want to raise the eyebrow and ask that question, how many grout lifts do you plan on doing, and what type of grout are you using, are great questions to ask. And so that's why I share this slide with you folks. This list was actually born from this Connecticut DOT job that you're seeing a picture of, and I've maintained using it throughout the industry just as good practice.
Great.
Is this, I think this might be our last or second to last slide, Cassie?
Yep.
Yeah.
I mean,
Okay. So, yeah. So, you know, I mentioned it briefly for the folks here. I know there's some DOTs on the call. I think it's worth just tapping into the idea that we've talked mostly about conduit pipes, annulus fills, and void fills, but which you see there highlighted in yellow. But for those who may or may not be aware, there's multiple applications for low density cellular concrete, and this being a all things grout webinar, I figured, hey, you know, we might as well mention grouts being utilized other than annulus applications. So
sure.
just want to scrape the tip of the iceberg here. So yeah, you can click right through those, Cassie. This is basically just kind of highlighting what we've talked about. There you go. And
Yep.
so I want to thank you again, and by all means, feel free to email Cassie and I any questions. And thanks so much for everyone's time.
Yeah, thank you guys. Really appreciate y'all staying on for a whole hour. We are going to have more of these coming at you next week and the following weeks. I've got 2 a week, every Tuesday and Thursday. I'm scheduling Reline Lives. Next Tuesday, we have Hydrotite. It is a joint repair system. Heather will be joining me for that on Tuesday. You guys can register for those at tvpipesolutions.com. And then there's a section under social that says Reline Live. Have a great afternoon. Thanks again, Dawn. I really appreciate it. We're going to be doing this grouting one. I have a feeling sooner rather than later. So thank you guys.
Sounds great. Have a great afternoon.
Yep, you as well.
Thanks.